Okay, so these are our notes for Monday, and we have a couple topics to cover. All right, so the topics about this lesson in this lesson will be speed, how velocity and acceleration are related. Also, we have to start talking a little bit more about the relationships between the graphs of f, f prime, and f double prime. And a third topic, we're going to learn a new derivative rule. And that is the chain rule. Now, the thing about the chain rule is we're going to bring in a lot of our algebra skills. So let's be ready, because that algebra is not the rule, but it's the algebra that the rule needs to finish it. That seems to get tricky. Okay, so first you're going to need your book. And I want you to turn to page 129, number 115. This question was for homework. And I'm going to talk about it quickly. So on page 129, all right, so the velocity of an object in meters per second is 36 minus t squared, where t is between 0 and 6. Find the velocity and acceleration of the object when t equals 3. So let's go ahead and find those values. The velocity when t is 3 is 36 minus 9, which is 27. To find the acceleration, we need to find the derivative velocity, which is negative 2t. So acceleration at 3 is negative 6 times 3, which is negative 6. And this will be in, let's see here, meters per second squared, and this is meters per second. Don't ever forget to write your, include your rate of change, how it's measured. Okay, so then it asks you about speed. Well, the relationship between speed when you have velocity and acceleration, because this is the rate of change of your velocity. And so if you know more about your rate of change and the value of velocity, then you can make some conclusions about the speed. Now, we already talked about speed equals the absolute value of velocity. This just represents its magnitude. It doesn't tell us whether it's speeding up or slowing down. But to tell you if it's speeding up, then velocity and acceleration must have the same sign, meaning they both are positive or they're both negative. If they're both positive, that type of graph means that if velocity is positive and acceleration is positive, that means the rate of change of velocity, the tangent lines, will always have a positive slope. It's speeding up quickly. Or if velocity is negative and acceleration is negative, notice that the tangent lines are also getting steeper quickly, getting more negative. These are examples of a particle speeding up. Velocity and acceleration have the same sign. Now, let's say that we had a graph of velocity, and it's decreasing. Notice your rate of change, their tangent lines, will have negative slope. So even though the value of velocity is positive, the value of acceleration is negative, meaning that my velocity is decreasing, therefore I must be slowing down. And if velocity is negative but acceleration is positive, then I'm also slowing down. All right, so not only this definition only tells you about a magnitude, a number, but to describe it in slowing down or speeding up, you need to look at acceleration and velocity. All right, the next one I want to look at is from page 128 in your book, page 128, and let's look at number 109. Look at numbers 109. Okay, they give you graphs, and they want you to determine which one is f, f prime, and f double prime. Well, you know that f's going to have the highest degree, so you know the next degree that the function with the next degree down would be the graph of the derivative. The graph of the highest degree is your nice cubic here, so he's f, this is f prime, and that's f double prime. All right, so work to number 110, and we'll talk about it in class first thing on Monday. Which graph is f, f prime, and f double prime. All right, you can put away your book and get out your notes for section 2-4. And we're going to learn the new derivative rule, which is the chain rule. Okay. So here's your definition of your chain rule. You got a lot of that derivative notation, and it looks kind of confusing. This one looks a little bit easier to understand. And this notation says, given a function with a function inside, this is called your inner function, then its derivative is the derivative of the outer function times the derivative of the inner function. So you must identify what the outer function and the inner function is. The inner function is easy. It's a little bit more difficult doing the outer function. All right. The derivative of the outer function, usually use the power rule when you take the derivative of the outer function. So we kind of look for things where we can write an exponent form. That's not always true, especially when you have a trig question. But we try to put things in a form where we can take the power rule times the derivative of the inner function. So before you can use the chain rule, you've got to get it ready, and you have to rewrite the function sometimes. Now, this first example, we know we can use the quotient rule, but we want to use the chain rule, so let's get it ready for the chain rule. I'm going to rewrite it as x plus 1 to the negative 1 power. So notice now I have it ready to identify an inner function and an outer function. My inner function is going to be x plus 1. My outer function is the parentheses raised to the negative 1 power. That's nice because now it's obvious I can use the power rule with this part of the function. All right, so here we are. Y equals x plus 1 to the negative 1. I'm going to take the derivative. So the derivative of the outer function, I'm going to pull my negative 1 in front, subtract 1 from the exponent, times the derivative of the inner function. The derivative of x plus 1 is 1. So in simplest form, it's negative 1 over x plus 1 squared. Again, you're going to be doing a little bit more algebra with these derivative rules. Okay, my next one, y equals sine 2x. I'm going to work this in the corner over here. Well, my inner function is the 2x. My sine is the outer function. 2x, I have to choose x, then multiply by 2. That's why it's the inner function. And this is the thing happening to 2x. So that's my outer function. All right, so the derivative is the derivative of the outer function, the inner stays the same, times the derivative of the inner function. All right, I can't use the product rule. I have to use the chain rule. All right, here we go. So the derivative of sine is cosine. Inner function stays the same, times the derivative of the inner function, which is 2. So the derivative is 2 cosine 2x. All right. I've run out of space, so I'll get another piece of paper. And the third example, I'm going to prepare it to use the chain rule because the square root acts as an outer function. And I know I can write that as a fractional exponent. You want that fractional exponent because now you can use the power rule. So taking the derivative, 1/2 3x squared minus x plus 1 to the negative 1/2 times 6x minus 1. Okay, so now I've got to put this in simplest form. 6x minus 1 stays in the numerator. The 2 and the polynomial will go to the denominator. So making you remember your algebra rules. And we're going to do some factoring in here also on some of these problems. The fourth one, y equals tangent squared x. Well, we really can rewrite this to say tangent x squared. Now this is nice little example of the chain rule. So I'm going to pull my exponent in front. 2 tan x to the first times the derivative of the inner function, secant squared x. So the derivative is 2. I'm going to rewrite it using a commutative property, make it look a little bit nicer. All right, so we're practicing using the chain rule, and sometimes we have to identify when to use the chain rule and when to use the product rule and the different possibilities. All right, so this is a chain rule because it has a function, an outer function. This is chain rule, and I can rewrite that key root as to the 1/3 power. All right, so I'm going to take the derivative with respect to x of both sides of this equation. So dy dx equals, I'm going to use the chain rule because it's my outer function, 3x squared plus 1, 3 minus 1 is 2, times the derivative of the inner function, which is 2x. So in simplest form, dy dx equals 6x x squared plus 1 squared. All right, you try that one and have it ready for class on Monday. Let's skip down to this one. I'm going to rewrite it so that I can possibly use the chain rule because I like the power rule. All right, so using my laws of exponents, this is x squared minus 1 to the 2/3 power. We can go ahead and simplify that part. This can be your outer function, and that's your inner function. So the derivative is 2/3 x squared minus 1 to the negative 1/3 times 2x. We can't leave it looking like that. We're going to simplify it. So that's 4x over 3 x squared minus 1 to the 1/3. All right, so be ready on Monday to discuss